Good morning, class. Today we are going to learn about the mole. Okay, before we get started, the learning outcomes. At the end of this presentation, you will be able to explain what a mole is, convert from moles to grams and from grams to moles, and go on and complete the worksheet that goes with this presentation. So why are we going to learn about the mole? Well, it's a central concept in chemistry. In chemistry, we're dealing with lots and lots of teeny tiny particles, including atoms and molecules. Often, we need to know how many of these teeny tiny particles there are in a substance. The mole allows us to count them. Now, this is hugely significant in chemistry, and we'll talk more about this later on. Let's start, though, with a basic concept from maths. A mole is a number. It's a number of things. We use it in chemistry to count tiny things, such as atoms or molecules. If you understand what a dozen is, then you will understand what a mole is. So let's just remember from your maths. What is a dozen? A dozen is 12 things. It doesn't matter what they are. A dozen eggs is 12 eggs. A dozen Mars bars is 12 Mars bars. 2 dozen jelly beans is 24 jelly beans, like you have in front of you. So just remember this. Just like a dozen is always 12 things, a mole is always 6 by 10 to the power of 23 things.
Say what?
Yep, it's a huge number. 6 by 10 to the power of 23. That's a 6 with 23 zeros after it. Don't be afraid of this, though. Yes, it's a huge number, but it's always the same. So remember what we said earlier. In chemistry, we're counting teeny tiny things, so we need this huge number to help us count them, because there are so many of them. 6 by 10 to the power of 23 is called Avogadro's number, because that's the name of the scientist that came up with this concept. So 1 mole of anything contains 6 by 10 to the power of 23 of that thing. 1 mole of jelly beans, for example, would contain 6 by 10 to the power of 23 jelly beans and would actually be the size of the planet Earth. That's how many of them there would be. Imagine that.
A mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Now say you had a mole of pennies to distribute round the world. Give to each of the 5 billion grown-ups, boys and girls. There wouldn't be a single soul down and out of luck, 'cause everybody in the world would get $1 trillion. Or say you had a mole of paper and stacked it toward the sky. Paper's awful thin, but that pile would get so high, you'd reach up into outer space. In fact, I think you'd find it'd go up to the moon and back 80 billion times. And a mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend.
Okay, so atoms are much smaller than jelly beans, obviously. The container on your bench contains 1 mole of sulphur atoms. That's 6 by 10 to the power of 23 sulphur atoms. So you see, when you're dealing with something as tiny as atoms, a mole doesn't actually take up that much space. A mole of sulphur atoms? How do I know that I have 6 by 10 to the power of 23 sulphur atoms in this container? I didn't count them out, obviously. They're way too small and way too many. So how do I know? Well, here's the great news. The mass in grams of 1 mole of each element, like sulphur for example, is given to us on the periodic table. This is called the relative atomic mass, or the molar mass, the mass of 1 mole. So for sulphur, for example, you can see that the mass of 1 mole of sulphur atoms is 32.066 grams. So when I was weighing out 1 mole of sulphur to show you, I looked up the relative atomic mass of sulphur on the periodic table. I saw that it was 32.07 grams, and then I was able to weigh out 1 mole of sulphur atoms. Guys, this was a very, very exciting discovery in chemistry. The mole is hugely important in chemistry in the real world. Atoms and molecules are so tiny that we couldn't possibly work with individual particles. We can't even see them. We need to be able to work with amounts that we can see and weigh, and they need to be in the proper proportions. The mole allows us to do chemistry. The fact that we can weigh out the relative atomic mass of any element on the periodic table and know that this amount contains exactly 1 mole, 6 by 10 to the power 23, of those atoms is very exciting for chemists. It allows us to manage reactions, for example. Okay guys, we're going to look at a quick example of converting moles to grams. So what is the mass in grams of 3 moles of aluminium atoms? So the first thing you do is you go to your periodic table, look up aluminium, and you see that the relative atomic mass there is 27 grams. So 1 mole of aluminium is 27 grams. 3 moles of aluminium is 27 grams by 3 equals 81 grams. In our next example, we'll look at converting grams to moles, so going the other way. So how many moles are in 36 grams of carbon? So again, you go straight to your periodic table and you see that 1 mole of carbon weighs 12 grams. So 12 grams of carbon equals 1 mole. 1 gram of carbon equals 1 over 12 moles. 36 grams of carbon, which is what you're asked for, equals 1 over 12 by 36 moles, which is 3 moles. And that's your answer. We're going to look at a lot more of these examples in the worksheet at the end of this presentation. Okay, so let's just review our learning outcomes. Can you explain what a mole is? Yes, you can. A mole is a specific number of particles of a substance. Specifically, it's 6 by 10 to the power of 23 particles. A mole is a number. Can you convert from moles to grams and from grams to moles? Yes, you can, because the mass in grams of 1 mole of all of the elements is given to us on the periodic table. That's the relative atomic mass, or the molar mass. And now we're going to go and complete the worksheet together that goes with this presentation.